Hello students, in today's class. Hello students, in today's class we are going to solve NCERT exercise problems 5.1 to 5.2, 5.4, 5.6 to 5.7, 5.9 to 5.12 on work energy and power. So this is disclaimer. Learning objective: by the end of this lecture you will be able to solve questions on work energy and power by applying concepts of work energy theorem, and conservation of mechanical energy using proper reasoning and calculations. So, exercise problems, work energy and power. There are 23 questions in this exercise. We are going to cover 9 questions: 5.1 to 5.2, 5.4, 5.6 to 5.7, 5.9 to 5.1. So, question is: the sign of work done by a force on a body is important to understand. State carefully if the following quantities are positive or negative. So in these questions, there is a 5 statements, and you have to find out the which statement is positive and which statement is negative. So A is: work done by a man in lifting a bucket out of a well by means of a rope tied to a bucket. B is the work done by the gravitational force in the above case. C, work done by friction on a body sliding down an inclined plane. And D is work done by an applied force on the body moving on a rough horizontal plane with uniform velocity. And E is work done by the resistive force of air on a vibrating pendulum in bringing it to rest. So you have to find out the which one is positive or which one is the negative sentence. Think about it. Let's see the solution of each statement one by one. So first is here we will learn the concept uh, that is important to solve this question. So work done by applied force F is, suppose we have a block, and we applied some force F. So there is a displacement D with angle theta. So in that case, work done by a force F on a body obtain a certain displacement when we applied force. So the formula of the work done we know, F dot D. So it will be FD cos theta. Here theta is the angle between applied force and displacement. Clear? So now A, work done by a man in lifting a bucket out of a well by means of a rope tied to the bucket. So the answer is positive, because in this case force applied by a man and displacement of bucket are in same direction. It means the force applied by a man is vertically upward, and displacement of bucket same vertically upward. So we can say both are parallel. If two quantities, or we can say if two terms having their direction is parallel, so in that case theta should be 0 degree. So now we will use the formula of the work done. So using the formula of the work done, here W is equal to FD cos theta. So theta is 0 degree because both have both bucket and rope parallelly, lifting parallelly. So cos 0 degree 1. So it means FD, W is equal to FD. So it shows greater than 0. So sign of work done is positive. Yes or no? So we can say A is positive. Clear? Now B, work done by gravitational force in the above case. So work done by the negative gravitational force in this case is negative. So in this case, the direction of gravitational force is vertically downward. Yes or no? And the displacement vertically upward. So here direction of gravitational force and the direction of displacement both are anti-parallel. If both are anti-parallel, it means theta should be 180 degree. So now we will use the formula of the work done. That is FD cos theta. But we know theta is 180 degree because gravitational force and here gravitational force and bucket both are anti-parallel. So cos 180 degree is negative. So we can say sign of work done is negative. So minus FD is less than 0. That's why our answer is negative. Clear? Let's see talk about the C. Work done by friction on a body sliding down an inclined plane. So the answer is negative. So in this question, body sliding down on an inclined plane. So here the direction of frictional force F is opposite to the direction of motion. If block sliding in downward direction, so the opposite of this direction friction will be act. So in that case, work done by the frictional force is negative. So FD cos 180 degree because here theta is 180 degree because the angle between block frictional force and sliding, or we can say displacement, both are anti-parallel. So here W is equal to minus FD, which is less than 0. So we can say the answer is negative. Clear? Now D, work done by an applied force on a rough horizontal plane with uniform velocity. So in this case, body is moving on a rough horizontal plane. So suppose we have a body, this one, and we applied force F in forward direction. So there is a frictional force that opposes the motion of the body and acted in the opposite direction of the applied force. So frictional force F opposes the motion of the body. Yes or no? Because the applied force in forward direction and friction will act opposite direction of the applied force. It means backward. So therefore, in order to maintain a uniform velocity, we uniform force F must be applied to the body. So now we know our answer is positive. So since the applied force acts in the direction of the motion of the body, the work done is positive because the direction of displacement and the applied force both are in same direction. So theta should be 0 degree. So theta is 0 degree. So FD cos 0 degree. It means W or we can say work done is positive because cos 0 degree is 1. So FD is greater than 0, which shows positive work. So now E. Work done by the resistive force of air on a vibrating pendulum in bringing it to rest. So answer is negative. So resistive force here, that is Fr of the air, acts in the direction opposite to the direction of motion of the pendulum. The direction of the uh, pendulum is backward, so the resistive force will act forward direction because both are opposite to each other. Hence the work done is negative in this case. Why? Because the angle between here angle between resistive force and up friction resistive force and displacement is negative, anti-parallel. So theta is 180 degree. So W is equal to minus FRD, which is less than. It means the work done by the resistive force of the air on the vibrating pendulum in bringing it to rest is negative. A body of mass 2 kg initially at rest moves under the action of applied horizontal force of 7 Newton on a table with coefficient of kinetic friction is equal to 0.1. Compute the first work done by the applied force in 10 seconds, B work done by the friction in 10 seconds, C work done by the net force on the body in 10 seconds, D change in kinetic energy of the body in 10 seconds, and interpret your results. So you have to find out the 4 thing here. A 4 option. Correct answer. You have to find out the 4 answers. A, B, C or D. For A, B, C, D. So let's see the solution of this question. Given mass of the body m is equal to 2 kg. Applied force 7 Newton. Coefficient of kinetic friction, that is 0.1, and initial velocity is 0 because initially the body at rest. So their initial speed is 0. Time t equal to 10 seconds. So let's see. Let's discuss about the key concepts of this question. First of all, we will know. First of all, we will discuss about the concepts which is useful in this question. So free body diagram. Here the applied force is 7 on a horizontal surface is 7 Newton. Suppose applied force is F, and the kinetic frictional force act in the opposite direction of the motion, and kinetic friction is 0.1. Now acceleration produced in the body by the applied force F we can calculate using the Newton's second law of motion. So according to Newton's second law of motion, F is equal to mass into acceleration. where m is the mass of the body. Clear? So acceleration will be force upon mass. Now we know force is 7 Newton and mass is 2 kg. So acceleration will be what? 7 by 2. So A prime, or we can say acceleration, is equal to 3.5 meter per second square. Clear? Now, second situation. The kinetic friction is given as Fk is equal to mu k n. So here the weight of the body is acting vertically downward and normal reaction vertically up. So n is equal to mg. But the kinetic friction here is mu k n. So n is the normal force acting between the body and the table. So now here, since there is no vertical motion, the forces in the vertical direction balances out each other. So if we talk about in vertical direction, there is a no net force. So n is equal to mg. Yes or no? So kinetic friction force is then defined as Fk is equal to mu k m. Here mu k is equal to 0.1. This is given in this question. Also m is equal to 2 kg and acceleration due to gravity is 9.8 meter per second square. When we put this all given terms in the formula of Fk, you will be get 0.1 into 2 into 9.8. So after multiplication, it will be 1.96 Newton. It means the frictional force is 1.96 Newton. Frictional force is negative because it opposes the motion of the body on the table. So Fk is equal to minus 1.96 Newton. Clear? Now, acceleration A double prime produced by the frictional force Fk can be calculated using Newton's second law of motion. So according to Newton's second law of motion, force is equal to mass into acceleration. So acceleration will be what? Force upon mass. So just put the value of force, frictional force and mass. So it will be what? Minus 1.96 divided by 2. So when we solving, so acceleration will be minus 0.98 meter per second square. This is the acceleration produced by the frictional force, minus 0.98 meter per second square. Clear? So total acceleration of the body, A is equal to A prime plus A double prime. So A prime is 3.5 plus A double prime is minus 0.98. So when we adding, so it will be 2.52 meter per second square. So now the distance traveled by the body is given by the equation of motion. So it will be S is equal to ut plus half at square. So S is equal to initial speed 0 plus 1 by 2 into acceleration is 2.52 and time is 10 seconds. So square of 10. When we solving this, you will be get S is equal to 126 meter. Clear? Now, work done by the force F on the body over a certain displacement S is given by F is equal to F dot S. So here theta is angle between force and displacement. So W is equal to Fs cos theta. Now, let's see our questions. First is work done by the applied force. So here we know W is equal to F S cos 0 degree, because the angle here, the applied force and displacement both in same direction. So W is equal to Fs cos 0 degree. So F is 7 and S is 126. We already calculated the F and S. F is given here. S we already calculated. So when we multiplying both, you will be get WF is equal to 882 joule. 882 joule. Clear? Now B, work done by the frictional force. So the formula is Fk, WFK is equal to Fk S cos 180 degree, because here in this case theta is 180 degree. So when we solving minus 1.96 into 126, W is equal to minus 246.96 joule. It means the work done by the frictional force is equal to minus 247 joule approximately. So now net force can be calculated as frictional force and applied force. So we know frictional force, that is minus 1.96, and applied force 7. So when we adding these two quantities, we will get 5.04 Newton. Clear? So work done by the net force. Let's see. So net force into displacement. So 5.04 into 1.26. So it will be 635.04 joule, which is approximately equal to 635 joule. So D, change in kinetic energy of body in 10 seconds. So from the first equation of motion, final velocity can be calculated as V is equal to U plus AT. So U is equal to 0, A is equal to 2.52 meter per second square, and T is equal to 10 seconds. So substitute this value in this equation. So you will be get V is equal to 0 plus 2.52 into 10. So when we solving, we will get V is equal to 25.2 meter per second. Clear? Now change in kinetic energy is final kinetic energy minus initial kinetic energy. So final kinetic energy is half mv square, because here speed is the final. Initial kinetic energy half mu square. So when we solving this, 1 by 2 m is the common, so remaining term is 1 by 2 m v square minus u square. Now using the form of the change in kinetic energy, this one, substitute the values, you will be get 1 by 2 into m, that is 2, final velocity 25.2 meter per second square, and initial is 0. So when we solving this, you will be get delta k is equal to 25.2 whole square. It means delta k is equal to 635 joule approximately. So change in kinetic energy is this. Clear? So results obtained the work energy theorem, because the work done by the net force is equal to the change in kinetic. So this is proof. This is proof of the work energy theorem. The potential energy function for a particle executing linear simple harmonic motion is given by v of x is equal to kx square divided by 2, where k is the force constant of the oscillator. For k is equal to 0.5 Newton per meter, the graph of v of x versus x is shown in figure 5.12. So that the particle of total energy is 1 joule moving under this problem must turn back when it reaches x is equal to plus minus 2 meter. So please think about it and solve this question. Let's see the solution. So, given total energy of the particle E is equal to 1 joule. Force constant K is equal to 0.5 Newton per meter. Kinetic energy of the particle K is equal to half mv square. And potential energy of the function v of x is equal to 1 by 2 kx square. So according to conservation of law, total energy is equal to sum of potential energy plus kinetic energy. So total energy is 1 joule, potential energy is 1 by 2 kx square, and kinetic energy is 1 by 2 mv square. Yes or no? So at the point of turn back, the velocity v and hence kinetic energy becomes momentarily zero. So total energy 1 joule. So A is equal to 1 by 2 kx square. This is potential energy plus 0. And kinetic energy here is 0. So 1 is equal to 1 by 2 kx square. So just put the value of k, that is 0.5. So 1 is equal to 1 by 2 into 0.5 x square. So now we will solve for x. So solving for x, 1 is equal to 1 by 4 x square. X square is equal to 4. X is equal to plus minus 2 meter. So hence the particle turns back when it reaches x is equal to plus minus 2 meter. It means maximum at this point. Particles turns back. Clear? Underline the correct alternative. First is, when a conservative force does positive work on a body, the potential energy of the body increases, decreases, remains unaltered. B is, work done by a body against friction always results in a loss of its kinetic potential energy. C, the rate of change of total momentum of a many particle system is proportional to the external force, sum of internal forces on the system. D, in an inelastic collision of two bodies, the quantities which do not change after the collision are total kinetic energy, total linear momentum, total energy of the system of two bodies. So here you have to just underline the correct alternative. Think about it and please solve this. Let's see the solution of this question. So if we talk about A, so answer is decreases. For conservative force, the work done by the force W and the change in potential energy delta V are related by that the relation is WC is equal to minus delta V. And when work done by a conservative force is positive, so WC is positive here. In that case, minus delta V is greater than 0. So delta V is equal to less than 0. Now A decreases since delta V is equal to change in potential energy, that is final potential minus initial and potential. So potential change in potential is negative. This means the potential energy decreases. Therefore, when conservative force does positive work on a body, the potential energy of the body decreases. Clear? Now B kinetic energy. The answer of B statement is kinetic energy. When a body does work against friction, in that case, force of friction acts in the direction of opposite motion. So friction is a non-conservative force. So in that case, the work done against the friction is always negative. So according to work energy theorem, W is equal to change in kinetic energy. It means final kinetic energy means initial kinetic energy. Now here work done due to friction is Fd cos theta. Now F is the frictional force, D is the displacement, and theta is the angle between force and displacement. So because friction opposes motion, so theta is equal to 180 degree because both are anti-parallel. So just put the value of theta in the formula of the work done, that is Fd cos theta. So you will be get Fd cos 180 degree. Cos 180 degree is negative, minus 1. So work done by the friction is equal to minus Fd. Since work done by the friction is negative, so change in kinetic energy be negative, because we know W is equal to change in kinetic energy. Means work done is equal to change in kinetic energy. That's why here we say uh, work done by the friction is negative. So we can say change in kinetic energy must be negative. So and negative change in kinetic energy means final kinetic energy minus initial kinetic energy is less than 0. It means initial kinetic energy is greater than final kinetic energy. So we can say when work is done against friction, it results in a loss of kinetic energy of the body, because here initial kinetic energy is greater than final kinetic energy. That's why we here called loss of kinetic energy in this situation. Clear? Now see, the answer is external. According to Newton's third law, internal forces between particles within a system occur equal and opposite pair. So mathematically, for a system, it will be rate of change of momentum is equal to net applied force. So dp upon dt is the rate of change of momentum. F external is the net force, net external force. Yes or no? So here internal forces cancel each other out. So for every force on first due to second, or we can say force on first particle first by second, there exists F21 is equal to minus F12. Here this means F21 means force on second particle due to first particle, and F12 means force on first particle due to second particle. Negative sign shows the in opposite direction. Therefore, the net internal force is 0. Only external forces contribute to the change in total momentum of the system. Clear? Now, D, total linear momentum and total energy. So, in an inelastic collision is one where the kinetic energy is not conserved. It means final kinetic energy is less than initial kinetic energy. So some kinetic energy is converted to other forms like heat, sound. So due to this conversion, initial kinetic energy is greater than final kinetic energy. So linear momentum conservation here is linear momentum is always conserved in collisions. So initial momentum is equal to final momentum. If the system of the two bodies is isolated, then the total energy is also conserved. Next question. Question is state if each of the following statements is true or false. Give reasons for your answer. First is A is in an elastic collision of two bodies, the momentum and energy of body is conserved. B, total energy of system is always conserved no matter what internal and external forces on the body are present. C, work done in the motion of a body over a closed loop is zero for every force in nature. D, in an inelastic collision, the final kinetic energy is always less than the initial kinetic energy of the system. Please think about this and solve this question. Let's see the solution of this question. So, A is false. The reason in an elastic collision between two bodies, the total linear momentum and total mechanical energy of the system for both bodies combined is conserved, not of each individual body. Total mechanical energy means sum of kinetic and potential energy. So, the conservation of law states that the linear momentum before collision of the particle is equal to the linear momentum after collision. Both are equal. This is the according to the conservation of momentum. So, according to conservation of kinetic energy of the system before collision is equal to the kinetic energy of the system after collision. This is only for this is valid for elastic collision here, where I is the initial and F is the final state. So, individual body can and usually do exchange momentum and kinetic energy during the collision, but their sum remains constant. Clear? Now, B is false because total energy of system is conserved only when there is no external forces doing work on the system, or all the external forces are conservative. If the external non-conservative forces like frictional force with external bodies acts on the system, they can dissipate energy to the surroundings and total energy is not conserved. The presence of internal forces does not affect the total energy of the system as they cancel out the effect of each other. So total energy of an isolated system is always conserved. Clear? So C is false. Work done in the motion of a body over a closed loop is zero for every force in the nature. This is false. So work done over a closed loop is not zero for every force, only for conservative force. Work done over a closed loop is not zero for every force. This is applicable only for conservative force. So work done over a closed loop is zero if the force is conservative. Examples of conservative forces like electrostatic force. So examples of conservative force where work done over a closed loop is zero is gravitational force, elastic force, electrostatic force. So these are the examples of conservative forces. So work done by these forces, gravitational force, elastic force, and electrostatic force over a closed loop is always zero. Remember this point. Always zero. So if we talk about the C, the work done in the motion of a body over a closed loop is zero for every force in nature. So for non-conservative forces, the work done depends on path, does not depend on initial and final. So energy is dissipated during the motion. So examples of non-conservative forces where work done over a closed loop is not zero. Frictional force, air resistive. Clear? So these are the examples of non-conservative. So D, in an inelastic collision, the final kinetic energy is always less than initial kinetic energy of the system. In an inelastic collision, some of the initial energy is converted to other forms of energy like heat, sound. So, some rare cases like explosive separation, the final kinetic energy can actually be greater than initial kinetic energy. This is happen in rare cases. So, this happens when other forms of energy like chemical potential energy are converted into kinetic energy during the collision. So, D here false. So, mathematically, let's see. For most inelastic collision, kinetic energy, initial kinetic energy is greater than final kinetic energy. And but in some cases, when other energy sources are involved, in that case, final kinetic energy is greater than initial kinetic energy. So, total energy of the system remains conserved. So, according to conservation of energy, total energy of the system is equal to the sum of potential energy plus sum of kinetic energy plus sum of other forms of energy like heat, like sound. So, total energy of the system remains conserved. Therefore, while it's common for final kinetic energy to be less than initial kinetic energy in elastic collision, it's not always. A body is initially at rest. We have a body, and body is initially at rest. It undergoes one dimensional motion with constant acceleration. The power delivered to it at time t is proportional to what? So there is a some uh, option. There is a options, and you have to find out the power is delivered at time t is proportional to on what factor. Given options: option A, t raised to the power 1 by 2. Option second is t. Option third, t raised to the power 3 by 2. And option 4, t square. Think about it. Let's see the solution of this question. So the given quantities, mass of the body is m, acceleration of the body is a. Using Newton's second law of motion, the force experienced by the body is given by force is equal to mass into acceleration. So both m and a are constants. So hence force will also be constant. It means F is equal to constant. Let this is equation first. Now for if we talk about the velocity, so for velocity acceleration is given as a is equal to dv upon dt, rate of change of velocity. So now here acceleration is constant. So to solving this question in very easily method, so just here we assume that a constant term, that is c1, because here a is the acceleration. So dv is equal to, here c1 is a constant into dt, because acceleration is constant. So now integrating both sides, we get integration 0 to v dv is equal to 0 to t c1 into dt. So dv integration of dv 0 to v is equal to c1 into integration 0 to dt. So integration of dv is v limit 0 to v and c1 as it is, because this is constant term, and integration of dt is t limit 0 to t. So when we putting the limit, it will be v minus 0 is equal to c1 and t minus 0. So it will be v is equal to c1 into t. So from this relation, it is clear that velocity is directly proportional to t. Yes or no? So power is given by the relation. The relation is force into power is equal to force into velocity. So using equation first and second, we will calculate the relation. F is equal to constant. This is equation first, we know. Second equation is v is directly proportional to t. So using this equation, so power is directly proportional to t. When we use these two equations first and second, from these two equations, this is clear that power is directly proportional to t. Hence the power is directly proportional to t. A body is moving unidirectionally. Unidirectionally means same direction on a single path. Under the influence of a source of constant power, its displacement in time t is proportional to what? Given options: first t raised to the power 1 by 2, option second t, option third t raised to the power 3 by 2, option fourth t square. So which one is correct? Think about it and please solve this question. Let's see the solution of this question. So the correct answer is third, t raised to the power 3 by 2. Power is given by the relation, that is P is equal to F into V. Now we know power force is mass into acceleration. So just put here, you will get power is equal to mass into acceleration into velocity. So we know velocity is here v and acceleration is a. So we know acceleration is dv upon dt. So it will become p is equal to mass into velocity and a become dv upon dt. So k is equal to mv into dv upon dt, because here power is p is constant. So we assume p is equal to. So it will be v dv is equal to k by m dt. So solving this further, you will be get after integration both sides, integration 0 to v v dv is equal to integration 0 to t k by m dt. So it will be 0 to v v dv is equal to k by m integration 0 to t dt. So here after integration it will be v square by 2, limit is 0 to v, and it will be k by m into t, limit is 0 to t. So when we putting the limit, you will be get v square minus 0 divided by 2 is equal to k by m t minus 0. Yes or no? So solving for v, it will be v square by 2 is equal to kt by m. So v square is equal to 2 kt divided by m. So v is equal to under root 2 kt by m. Now here for displacement x of the body, we have v is equal to dx upon dt. So dx upon dt is equal to under root 2k divided by m into t raised to the power 1 by 2. So dx upon dt become k prime t raised to the power 1 by 2. Because here we assume under root 2k by m is k prime. So k prime is a new constant. So solving further, you will be get dx. So dx is equal to k prime t raised to the power 1 by 2 into dt. So integrating both sides, you will be get integration 0 to x dx is equal to integration 0 to 2 k prime t raised to the power 1 by 2 dt. So it will be 0 to x dx is equal to k prime is a constant, so comes outside. Remaining term is integration 0 to t raised to the power 1 by 2 into dt. So solving after solving the integration, it will be x, lower limit is 0, upper limit is so is equal to k prime. So integration of t raised to the power 1 by 2 is equal to t cube t raised to the power 3 by 2 divided by 3 by 2 with lower limit 0 to upper limit t. So this is just mathematical calculation. So solving this, you will be get here x minus 0 is equal to 2 by 3 k prime t raised to the power 3 by 2 minus 0. So x is equal to 2 by 3 k prime into t raised to the power 3 by 2. So x is directly proportional to t raised to the power 3 by 2. So this is our correct. Clear? A body constrained to move along the z-axis of a coordinate system is subject uh, to a constant force F is given by F is equal to minus I cap plus 2j cap plus 3 k cap Newton, where I cap, j cap, k cap are unit vectors along the x-axis, y-axis and z-axis of the system respectively. What is the work done by this force in the moving body at a distance of 4 meter along the z-axis? So here you have to find out the work done by the force. Please solve this question. Let's see the solution of this question. So the given terms is force F is equal to minus I cap plus 2 J cap plus 3 K cap Newton, and displacement D is equal to 4 K cap meter. So work done is given by W is equal to F dot D. So just put the value of F and D and take dot product. You will be get I cap dot 4 K cap plus 2 J cap plus dot 4 K cap plus 3 K cap dot 4 K cap. So solving the dot product, you will be get W is equal to 3 into 4, because we know I dot K is equal to 0, J dot K equal to 0, and K dot K is equal to 1. So this is the dot product properties. So W is equal to 12 joule. Clear? Hence 12 joule of the work done by the force on the body. An electron and a proton are detected in cosmic rays experiment, the first with a kinetic energy 10 kilo electron volt and second with 100 kilo electron volt. Which is faster, the electron or proton? Obtain the ratio of their speeds. Electron mass is given, that is 9.11 into 10 raised to the power minus 31 kg. Proton mass is 1.67 into 10 raised to the power minus 27 kg, and 1 electron volt is equal to 1.60 into 10 raised to the power minus 19 joule. So please think about it. Let's see the solution of this question. So given terms, mass of the electron is 9.11 into 10 raised to the power minus 31 kg. Similarly, mass of the proton and kinetic energy of the electron, that is 10 raised to the power 4 electron volt, and kinetic energy in joule 1.6 into 10 raised to the power minus 15, because we know 1 electron volt is 1.6 into 10 raised to the power minus 19 joule. So kinetic energy of the proton is 10 raised to the power 5 electron volt, and kinetic energy of the proton in joule, it will be 1.6 into 10 raised to the power minus 14 joule. So for the velocity of an electron, its kinetic energy is given by K is equal to 1 by 2 mv square. This is for kinetic energy for the electron. So VE, solving this, it will be become under root 2 into Ke divided by me. So now we will solving VE. So put the values of given terms in this relation. You will be get VE is equal to under root 2 into 1.60 into 10 raised to the power minus 15 divided by 9.11 into 10 raised to the power minus 31. So solving this, you will be get VE is equal to 5.93 into 10 raised to the power 7 meter per second. So this is the speed of electron. Now for the velocity of proton, its kinetic energy is given by the this one, half mv square. This is for proton. Similarly, velocity of the proton is under root 2 into kp divided by mp. So substituting the values, you will be get Vp is equal to under root 2 into 1.6 into 10 raised to the power minus 14 divided by 1.67 into 10 raised to the power minus 27. So solving this, you will be get 4.38 into 10 raised to the power 6 meter per second. So hence the electron is moving faster than proton. Clear? So the ratios of the speeds is VE divided by VP is equal to 5.93 into 10 raised to the power 7 divided by 4.38 into 10 raised to the power 6. So solving this, you will get 13.54 ratio 1. So this is the correct answer. Thank you for your attention. If you have any doubt, please ask. If you have any doubt, please ask. Yes or no? Any doubt? That's all for the today.